question. Students, we are given this question, y times 1 negative x times tan x positive x squared times cos squared x, that entire quantity as a differential operator dx followed by negative x times dy equal to 0. So foremost what we will do is we will consider the given quantity, which is y of 1 negative x times tan x positive x squared times cos x, that is multiplied with the differential operator dx followed by negative x times dy equal to 0. Next, I would divide by dx both sides. So when I do that, this is going to be divided by dx and divided by dx. Of course, when you divide this by dx, you get 0. So on the right side, it's going to be 0. On the left side, you are going to have y of 1 negative x times tan x positive x squared times cos x. This is what you've got. Negative, see, this is actually negative, right? So I wanted to really make it as positive. So to make it as positive, what I would do, I would have to push it. So let me rewrite it first. So x times dy over dx. So this is what I've got. I want to make this as positive. So the only way it could be done, either you move this to the right side and you do the simplification, or you multiply by negative 1 both sides. Now when you do that, you would get negative of y times 1 negative x times tan x negative x squared times cos x positive x times dy over dx is equal to 0. This is what you would get. So now I want to write this first. So it's going to be x times dy over dx followed by negative, this is actually negative y, right? So what I would do, okay, let me write it first. So negative y of 1 negative x times tan x is equal to x squared times cos x. So I'm moving this to the right side. Okay, now I don't want to have a x here, so divide by x both sides. So when you divide by x both sides, this is going to be x divided by x, okay, times the dy over dx negative y of 1 negative x tan x divided by x is equal to x squared cos x divided by x. So this is what I've got. Now clearly the x that you see here will be cancelled. So these two will be cancelled. So you can just cancel it out. So if I were to do that, this is gone. 1x will be gone here. So that would give you dy over dx negative. Now I want to rewrite this. I want to take a negative sign out. So if I were to take a negative sign out, this will become positive y of, this would be actually, if you were to, the form would be something like this. So let me show that form to you. So the negative sign here, once you take it out, would become a positive sign. So this is going to be x times tan x with a positive sign. But the positive sign for 1 that you see here would become a negative. So that's going to be like this. X times tan x negative 1 divided by x. Okay, so just for the sake of understanding, let me show it here. You got negative y of 1 negative x times tan x, right? So what I'm doing is I'm taking a negative out. So if I were to take it a negative out, this 1 should be positive. So the only way it can be positive is to have a negative sign before 1. This has to be negative. The only way this can be negative is to place a positive sign there. So that's going to be positive x times tan x. So this is exactly what I am doing there. But I can move this negative. If I were to move this negative, this will become positive. So it's going to be positive y of negative 1 positive x times tan x, right? This is what I'm getting. Now I can always flip, or I can always write x tan x first followed by negative 1. This is exactly what I'm doing here. Okay, just for the sake of better understanding. Now on the right side I've got x times cos x Okay. Now this is of the form dy over dx positive p times y is equal to q, where my p is equal to x times tan x negative 1 divided by x. So this is what my p looks. Now I can rewrite this as tan x negative 1 over x. Okay. Now I need to know about the integrating factor. The integrating factor is actually e raised to the power integral p dx. This is nothing but e raised to the power integral. In place of p, I substitute tan x negative 1 over x, and that has to be followed by an operator dx. Now I would first consider integral p dx alone, which is nothing but integral tan x negative 1 over x times dx, which is integral tan x dx negative integral dx over x. From formula, this is going to be negative log of modulus cos x. This is nothing but negative log of x. Of course, you have a positive constant c. I don't need to place a constant c in this case. Now, this is written with the negative sign out. So that's going to be log of modulus cos x positive log of modulus x. So I would just want to have a positive x. So that's the reason I'm taking modulus. Now I know a formula. What is that? Log of a positive log of b is log of ab, right? So this is equal to negative of log of x times cos x with a modulus sign. Okay. Now I also know another formula. What is that? A times log b is equal to log of b raised to the power a. So this is rewritten as log of modulus cos x raised to the power negative 1. Now this can be moved down, right? Which can be rewritten as log of 1 over, of course there is a x here, so don't forget the x, that's critical. So this is going to be log of modulus x times cos x raised to the power negative 1. So I can push it down. That is going to be x times cos x, of course with the modulus sign. Now what is this? This is e raised to the power. In fact, this is just integral. This is not at e raised to the power. So this is just integral p dx. So this is the integration that we have got for integral p dx. So that's what we started with. Okay. Now we need to obtain the integrating factor. So therefore, the integrating factor, which is e raised to the power integral p dx, is equal to e raised to the power. This is log of 1 over x times cos x with a modulus sign. Okay, this is what we have got. So just place this value on the head of e. Now e and log will get cancelled. Okay, because of the fact that we are taking it as the natural log, right? So it's not other base. So because of that fact, I can rewrite this as 1 over x times cos x. Okay, so this is what I get as the integrating factor. I know now the integrating factor. Now we have to obtain the general solution. So therefore the general solution is given as y times e raised to the power integral p dx is equal to integral q times e raised to the power integral p dx times dx positive arbitrary constant c. Now we know that integrating factor is this. So it's going to be y times integrating factor 1 over x times cos x is equal to integral. Now my q is found to be as x times cos x. Okay, this is my q. So place that x times cos x times integrating factor is 1 over x times cos x times dx positive arbitrary constant c. Now clearly this x times cos x can get cancelled, will get cancelled. So this is going to be y times x cos x on the left side. On the right side is integral dx, positive arbitrary constant c. If you integrate this, you get x positive arbitrary constant c, and this is going to be y times 1 over x times cos x. So this is what I've got. Now I don't want to have x times cos x with y. So what I'm going to do, I'm going to multiply by x times cos x both sides. Okay, so when I do that, I get y is equal to x times x cos x positive c times x cos x. So this is what I am getting. I can rewrite this as y is equal to x squared times cos x positive c times x, or c times, depending upon what you want, you can write it. So this is going to be c times x cos x, and this would be my final solution for the question.